So welcome everyone for Cloud Computing and Big Data, or Lecture 8 today, Infrastructure as a Service. And this really is a topic you already heard in several lectures. And we will make a case for it, why we put it just now, basically in the curriculum, quite late in a way. But as you remember, we also were introducing lots of practical relevant stuff to get you early to the assignments. In a normal course, you would probably have that as lecture 2, lecture 3, lecture 4 with PAAS and SAAS and so on. So hence today we will come back to several aspects that we left out on purpose to get much more a practical start into the topic. And one of the practicals we have seen was the last time in practical lecture 7.1, when we talked about distributed deep learning, the idea of really doing this in cloud computing and understanding the scalability aspects of it, combined with the computational complexity that relies in the parameters, right? So we have been doing this journey since quite a while. In the beginning of the course, we did linear learning models with logistic regression. Now we have here around, and I should do the cursor here with the mouse, we have essentially the idea of doing this multi-output perceptron learning model, very trivial learning model, but still kept to the essence. And we have seen there are some parameters, which are essentially the weights that you got to learn, plus the biases for each of the different neurons. So not really very much in computational challenges. And this means also, in a way, the capacity and the capability of the model gives us just around 90%. Now, then we came across the idea of having a much more better learning model, which brings us then to the idea of a multi-layer perceptron. So simple elements are still the same, but you combine many of those. So we'd have hidden layers, which are called neurons, and where you combine lots of these together, and you have to pay the price for it. For instance, in this 2-layer hidden, artificial neural network, you basically see we have already 118,000 weights to train. So these are the weights we talk about here. And we also learned in the last lecture that this is different than hyperparameters, right? So hyperparameters here would be how many neurons are in each of the hidden layers. What would be the learning rate we use? What would be the optimizer? Here we're talking about purely the weights we have to optimize in each of the different steps: signal through, backpropagation of error, signal through, backpropagation of error, making it a supervised learning problem here. So then the step to deep learning was admittedly a little bit very specific. We used a convolutional neural network, so one of the deep learning networks, which is stand the test of time in terms of the capability, which was then about introducing different layers, really, right? You have the different ideas that you have still neurons in a way, but you have them arranged and you have capabilities like this feature maps, convolution operations, pooling layers, and so on, that make the deep learning network not just the deep learning in terms of different neurons, you have heard that before, but the really different emphasis on the architectures and so on, and the capabilities. So if you now think about autoencoder or transformer models, which are cutting edge deep learning models, these would be much more parameters even. So the last time we ended with the notion of saying we have 1.2 million parameters to train, which is again the weights of the network you see here. And this, of course, means lots of computational complexity. So some of you have maybe also started already with the assignment 2. So is that working? Some of them? Okay. Yeah, let's come into the break how that works. But the key message to take away is that there you basically at the end of the CPUs, right? So essentially these parameters with 1.2 millions, you will see also in your assignment, it will not gonna work. Right, that's where we need GPUs. Now, when you go to autoencoders with remote sensing data, what I also discussed in last lecture, you have much bigger models, much more computational capacity to do so. We learned also that different ways of doing it. One was the AMIs, the Amazon Machine Images, let's say very low level on the rather infrastructure as a service layer, and that's what we want to do today. And then we have seen the Amazon SageMaker, which is much more software as a service, right? And these are actually some of the abbreviations we want to clarify today in the next couple of weeks, because we left it a little bit out to really get you a kind of crash course to machine learning. And in order to get to these performance ratios, really with 95% performance or 99 performance, we have to work different, let's say, computational infrastructure issues, and one of them is to go across a node. In the toy problem we have is MNIST. Of course, this is not necessary, but if you talk about real problems in science engineering, we quickly leave the memory and the computing capacity of one node. So we have to have different nodes which are all equipped with GPUs in order to connect them. And there are different strategies. I showed you last time the data parallel one. So we do different data on these different nodes, train them separately, and with the average of the gradient, which is a learning in the parameters, we actually do the update of the learning in each web propagation step and will distribute it across all the nodes with MPI or reduce. This is implemented in a tool called Horowot, right? So it's one idea. PyTorch GDP does the same thing internally. And there's also nice connections that many elements of this course are directly related to high performance computing, which sits much more lower under cloud computing. And I will make a case for it again at the end of part 1 today. So let us look now again what we want to do. Coming back to the point that in normal cloud computing curricula, you probably have infrastructure as a service quite on top, together with platform as a service, and then you would start more applications. Again, based on student feedback, we inject here several topics for the assignment and practical, let's say, applications, really how to make use of big data early in the course. Hence, we left alone many conceptual aspects. We will now look in the next couple of weeks, basically around infrastructure, platform as a service, and software as a service. Before we come to the final, basically practical that you see there with big data analytics and so on. So today we go back to these different cloud levels, as they're sometimes called. We will establish these different functionalities on these different levels, but also we'll have a hopefully good idea of thinking that these are, so to speak, very much closely overlapping. There are no hard boundaries, right? It's very hard to classify them one by one. And I will make a case for it when we talk about MapReduce. For some, it's an infrastructure to work on. For some, it's a platform to operate with MapReduce. So this is a gray area again, and you have different choices really as a cloud computing user and provider to work on this. And we will talk about this today as well. Then we will review several different Amazon services that you already know, just to make the point again and connect to previous lectures where we hopped on the infrastructure as a service train very, very quickly and make the case again of pricing, configuration, ending at the notion of where you really want to go in a high scalability using, for instance, the EC2 ultra clusters, things we didn't discuss yet. And there we really touch upon high performance computing already. Right here, we're talking about using different P5 generations, maybe Hopper cards, combining them together, different nodes, and many of those in order to tackle real life problems. Having understood this, that of course, some of these topics then are relevant for the HPC course, much more low level, just knowing for you that these clusters exist and that you can use them in the cloud, of course, means we can also go to some application areas. There we have also some data services we have to talk about that you see here a little bit. The cloud storages we talk about, which have different facets. So far, we just looked in S3, right? The bucket store, if you remember. So this is a useful one. But of course, in many of these underlying services we have, we see also the elastic file system and so on. And I will make cases why you need also different storage services for different problems. Also, if you think about long-term storage, we talk about the glacier. It's quite nice here in Iceland to talk about these things. So what happens when you have really long-term storages and needs for storing data? Every now and then, also for the first part and the second part, I will come back to Icelandic data centers, to make the case that we, of course, have different providers in Iceland, like Verne Global, for instance, especially when you talk about the infrastructure as a service level. And yeah, we basically end a little bit with the idea of that the cloud goes even in the infrastructure as a service level quite broadly, right? So more and more these services are interlined with this platform as a service. And of course, also understanding that in many cases, the IAAS level gives you the foundation for doing this higher level services that we discuss on Thursday and then next week, again on Tuesday. Right, so it's a very unique system in a way. And we talked about this in the beginning, that already on cloud computing, in a sense, you can say there are many different vendors and many of you use these different services. I think that's pretty obvious. The point is also, if you think of all of them, they have somewhere an infrastructure as a service underneath, right? It's not maybe a service that you're going to use as an end user, right? If you think about the Google services that we use every day in Google Docs or Facebook, you don't really think that there's computing underneath. You just have your profile, you have friends, you have events. But underneath, of course, is a very smart way of Facebook of managing an infrastructure. And these were the things we basically left a little bit off when we talked about the prologue, when we talked about the introduction of the course, referenced and say, well, there are these 3 cloud service levels we talk about, and we do them later in the course. That was basically, lecture 4, then also with virtualized IT resources. We know that this has something to do with it. And you see a little bit here also this kind of virtualization topics where we talk about different services on different areas. Right, today we're talking about the infrastructure as a service level where we're really at the lowest front. So talking about really essentially storage, computing, and the network itself. But you will also see that the boundary to the next level, so really storage solutions, databases, but also maybe, as I told with you, virtualization, right? Creating in runtime operating systems on images already is sort of overlapping, right? Again, deploying a deep learning AMI on AWS could mean, well, you use an infrastructure for deep learners and provide it. For the deep learning people, the experts in your company, it looks rather like a platform I can use to do deep learning. So it's also in some ways a view, right, that changes. But we can definitely see that the offerings that you have on all these different levels are sort of a little bit different, and also from the complexity in terms of what you need really in terms of technology are also very different. Usually you swipe the credit card over here in the applications. On the platform level, you still need development, right? You have to pull in different Lego blocks to create your own elements. You have to code your own MapReduce application on top of a MapReduce infrastructure. And of course, in technology, then, if you want to create a custom built infrastructure for your company, you need to know about something, how to do computing at scale, and so on. So interestingly enough, different layers that stand the test of time. And today you can find even database as a service. You can find lots of as a service characters that have been derived in all different region areas. But let's say these are the core ones that in a way, are still relevant today. Take away the notion that, of course, you would combine them maybe also on a different level on different applications. Another question came up early in the course also about what happens when I have some sensitive data? What happens, let's say, if a healthcare provider wants to use also cloud computing, he would use his own private cloud. And how we do this, we will learn in OpenStack, for instance, how you create your own private cloud. You would still combine it with a public provider like Azure, Amazon, whatever, in order to maybe arrange some peaks or basically some, let's say, computing where the patient data really is aggregated or is anonymized. So you can take it to the public cloud and can then take the results back. So different areas of applications where you then combine these different layers. Hence, you see again a sort of level of this, right? But this is orthogonal to what we discussed just now with infrastructure as a service, platform as a service, software as a service. Here we rather talk about the combination really of different, let's say, access rules, how you can access the clouds and what makes it in the end a public, private, or a hybrid cloud in your company. Now talking more about these different levels, let's start from the top. The software as a service model, many of you know these already. On the top, where you have the real users, the end user in a sense, Zoho for things like CRM and so on. Google Docs you already use. So this is something where usually you have a contract with all of them. You basically swipe the credit card or have subscription models, renewals. Google does it for free, of course, but with a model of the idea that at some point in time you maybe want to pay for storage, and the Google Cloud is just very closely away from it. So also there are, of course, incentives laid out to get, let's say, into these different clouds and then get you hooked to do advanced services that you can also book already in the Google infrastructure. Coming to the next, platform as a service for you is a good example here, I think, where you see the different, let's say, Lego blocks, right, that you have on the PAAS infrastructure. So now we talk about between these different ones. So you would have an application that you really want to sell. The client interface is somewhere on the software service, so people swipe their credit card there. But me as a developer, I now have to do these applications as a launch. Let be an app application that we discuss in PAAS. Then, for instance, for Angry Birds or so, we monitor the quality of service because people pay for it. And all of these different building blocks are provided, but you create them together, for instance, in the Google Cloud, to create an application using the Google Cloud Platform for doing so. And all, for instance, different platform elements like billing and so on are already provided and managed with credit card providers, so that you as a developer create this platform for basically your company and your application yourself. Hence, there's a certain flavor of development cycle, right? Versions of different apps. Lots of things come on the platform character, which are relevant in this area. And then the focus really of today a little bit is the infrastructure as a service, the lowest level, which could mean also some varieties of this. Some would say that the database might be already something for the platform, right? So of course, these are elements where we then think, okay, MapReduce, as I was alluding to, master worker, like Apache Spark or so, you have the resources for it, but in a way, you already provide a platform for the next layer. So this is a gray zone again, when you think about the implementation of those. But if you think about the real underlying hardware, there we definitively are on the infrastructure as a service level, combined maybe even with a virtualization layer. And here I just want to make also maybe as an Icelandic lecture, a little bit marketing. We have many providers in Iceland that work on this level, the Borealis data centers, where we soon hopefully will take a visit to, as I promised you at the beginning of the course, the Atnorth data centers with different data centers in Akureyri, but he also across Iceland, Advani has different data centers. So it's not only a game that the big Amazon and MS Azures and Google and so play, it's also lots of providers in Iceland, and they may even have a good deal for you. For instance, a green and clean deal of thinking about that, of course, all the energy for these data centers here in Iceland are really green data centers. So let's have a video from our association Data Centers by Iceland about this, so that you understand a little bit the sort of slogan behind it. And I'm not paid by any of those, just that you know, right? So important is just here to promote Iceland a little bit as a data center orientation. You see us here at the Supercomputing Conference, for instance, in 2021, just after COVID, or basically partly in COVID still, with the Borealis data center guys, Advania, and so on. So let's see what Iceland has to offer here. So you see short promotion video with thanks to our Data Centers by Iceland Association, very neutral to all the data centers here in Iceland. So it's a good community in a way for us as academics to be part of, to push this. So of course, in the end, you have to make contracts with the real, let's say, data centers behind it. But it shows you that Iceland has also something to offer, despite the fact that the hyperscalers are very competitive in US and so on, of course. And talking about them, I provide this lecture more or less on Amazon, but take away the message that MS Azure and of course Google Cloud have very similar services, right? So in the end, you see all what you can do with the Amazon I showed you in a couple of lectures, and also in this lecture are in a way also possible with the different cloud providers. And they all follow the same idea that you get relatively rapid access. So if you have a credit card ready, you can run your job basically in 10 minutes, right? So that's very easy. Of course, you go there and pay the price for it. You have learned that by now. You have to pick the different pay by resource pricing schemes that you have seen with on-demand spots, for instance, in Amazon, but MS Azure and all others have, of course, the same elements. And then all the management of the infrastructure looks a little bit different in all the different AWS console, or you have seen this HD Insight also in Microsoft Azure. But in a way, they cover similar elements of monitoring, deploying, resource management, and so on. Very important, as you know, is by now the delete button, hopefully, right? So delete the cluster, stop the button, because otherwise you pay the price for the infrastructure and it will run continue, continue, continue. Hence, in the first assignment, I was always asking you when you want to use a cluster, because otherwise for 1 month running a cluster not used still means pricing for us, despite of your usage or not, because it's up and running, it's ready for service, so to speak, and that's where the costs come. And usually all operate along these lines. So there's some exceptions, of course, for the educations, AWS Academy, but I have seen over the last 5 years that also the free offers go incredibly down these days, right, in this public offerings. So just take away the message that many of the things I always say is very similar. By now, you already learned a little bit about this credit card swiping process. I think I can easily skip that or do that very quickly. You see just an example how the cost quickly can accumulate. A little bit the SageMaker demonstrations I did already were basically in the order of $180, right? For one small course lecture. Now think about a startup that has this to do 24/7 on a monthly basis, have developers on AI working on this daily. And if you remember, for the demo, I had very small ones even only. So, I mean, small CPUs and GPUs used. So this means something very quickly, how costs can accumulate. You see mostly for the SageMaker and taxes, of course, not forgetting this, of course. And then the EC2 compute and so on, of course, now that depends now on which resource you take. And I will come to a very extremely one that is very expensive in a moment. Also, when you see the number of services that are now leveraging the IAAS, right? AWS was very focused in the beginning of this. This is 2018. Now comparing to today, you see sexy topics like machine learning, right? So suddenly it was not on the horizon in 2018. Now, tons of it, plus analytics service that was already around a little bit, just called it a little bit artificial intelligence, but now things evolved really rapidly into this area. And also the same is true for every, let's say, other area where we see more and more uptake. And of course, the infrastructure services are still a very strong component, and also about containers that we will basically explore in one of our next lectures. How you access it, you already learned this. Basically, the idea is having these resources somewhere in the cloud, and you can access it via, for instance, SSH, or you use a SaaS service, which is now the point that the infrastructure as a service is a very flexible element in this. Having different resources, you can use, for instance, low-level access like the people from the administration domain would use, like MobiXterm. But you have also seen higher level services. You would combine this now, and that is now the point of going the next steps, right? In the next couple of weeks, we will talk about PAAS and IAAS and SAAS, and you have already partly used this. The infrastructure as a service is really the idea of the network, the EC2 computing entity. Then we have to use the Amazon Elastic MapReduce service, which is already a platform for those that want to run MapReduce jobs on this infrastructure. And you already learned I mean, in a way here, you see it on the right side, Amazon SageMaker Studio, the higher level services really are those that you then can easily reuse the infrastructure. Hence, they're all in a way combined, but usually the IAAS is really the flexible lowest level that you have, providing you really access to the hardware. The access to the hardware is usually, however, always in a way abstracted away through virtualization, as we did in lecture 4, explored for enabling basically this economics of scale, but also resource sharing and so on. Hence, you see many of the things connect now what we had already in the course, the EC2 with the parallel computing idea of doing it really as a large-scale HPC workload, for instance, using Horovod, as I just alluding to, with deep learning. You can use analytics with Elastic MapReduce that you already have done, basically with a MapReduce cluster, even if it's on Spark, that doesn't matter. So it's still basically the idea captures away from the worker and master paradigm. And of course, recently you also explored Amazon SageMaker. All of them have basically, if you remember, we always have to choose the EC2 instance. If we create an EMR service, if we create a SageMaker service, we always go back to the EC2, which exact computing you want to have. And that's where also then often some of the pricing comes from. Hence, the basis is really strong. And we have seen that you can also work alone on this basis with the AMI. So that's what we did the last time. And here's now the important point, right? We had the different instance types. here the T2 Micro, which was not so expensive. But if you really want to use deep learning with AMIs, we said we have to go a much other way, a much, let's say, more expensive way. It's leading us to the P3, P4, and P5 resources, which were there. If you remember, this was the GPUs basically on the different generations of NVIDIA GPUs, right? Talking about essentially the Volta architecture, the Ampere architecture, and the latest one, which is the Grace Hopper architecture, P3, P4, P5, you pick that. But then you see suddenly from 0.001 cent, you come to $30 an hour, which means a lot of change, of course, when you talk about this scale. Because normally you also don't want to have just one of them, right? So you would combine them. And this means also something to really look careful when you go to these cloud vendors. What is the usage model? So pay per use, pay as you go. There are some facets and nuances in the details where this is really different from classical computing. As I said, with the Hadoop cluster or the Apache cluster, if it's there, the HD Insight cluster, it charges you, even if nobody is using it. You provide the platform or the infrastructure, hence, this needs to be always on your horizon. There are other usage models sometimes when you basically have an auto scaling up and down, where maybe the pricing will be then, reduced if really nobody uses this. It's also possible. Hence, there are different payment models. I would always encourage you to look in the details, especially if you will be responsible for managing as a CTO, maybe the access to a cloud or so within one company or even the startup. Now, towards the end of the first part, maybe, we have to talk about one scale more, where we now think about, we talked about AMIs, connecting them and so on, but how would that look like? So when you now have here an idea, and actually Amazon calls it a EC2 ultra cluster, it has to be a marketing term that the people can refer to, that they know. In a way, you would say today it's a high performance computing in the cloud, right? Machine. All what you see here is that the different instances are very well interconnected. Here we have talked about the P4 generation of GPUs that are really, cutting edge GPUs at that time. P5 is the Hopper architecture. P4 is the Volta, is the Ampere, sorry. So you compare here a system which has inherently now different of these instances we singly picked in, SageMaker, if you remember. Right, we had put in SageMaker this different one of those, but now the ultra cluster directly comes with an idea of the network behind it for scaling and so on. And this is what you can directly book. Of course, now think about again, when we talk about this P4D, one of those, again, we talk about $30 an hour, right? This is going up and down, sometimes in the pricing a bit, but we still pay the price for it. If you talk about P5 generation, the new cluster, it goes up to $100 an hour for one from this cluster, right? And now you understand a little bit, and of course, the HPC course from me will go much more into details why EuroHPC exists for scientists, for engineering for free, because we would never able to afford something like this in science and engineering, right? It's impossible. 30 hours per hour, $30 per hour. And we have here just a small cluster. This needs to be provisioned. The beauty is when you get it in Amazon, everything is basically prepared for you. So whole network setup that you see between all this A100 GPUs. And of course, in an instant, you can scale up to maybe 4,000 GPUs. And this is something where, of course, there we talk about really, really large problems that we do, for instance, in remote sensing. If you remember, where we use lots of thousands of GPUs together with Horowat, with other elements to really break down the computing. And one of my PhDs, Rocco or so, he basically was computing this where we would spend millions, maybe even billions of euros just for his PhD, right? For all the papers we have done, when we would use these pricing models, we were in the millions of euros, which we could never afford. Hence, we have this access as scientists, as engineers working together with some companies for innovation, also, free of charge, because we would be quickly at the end when we just use Amazon. I just give you this as also an appetizer. Of course, I have to end here a little bit because we will dive more and more deeper into the topic of high performance computing, interconnects, how you connect different GPUs across NVLinks and NV switches, how the communication is done with all reduce and so on. But these are, of course, all topics you have in the high performance computing course, which is a complementary course coming in spring again. And here you see just an example that, of course, the generations keep going. Here's a P5 now, hence the Hopper, the Grace Hopper architecture, which is very hard to get also, right? So even if you order it today, there's a shortage. So it's also interesting that, of course, by getting to Amazon, you at least can get directly, you know, this cutting edge architecture. And here is just an example of the P5 instances here, where you have then 8 H100 or 8 H200 cards. But you have also then the necessary memory and, for instance, also the direct network interconnect with GPU direct RDMA interfaces, being able to connect between the different GPUs directly, sort of using the CPU more or less as a message channel. But again, this would be topics then to discuss in the HPC course. So I will basically end here the first part. Of course, I brought you a very small video, but I stopped the recording for this.